the answers to the Honors Module 5 test review. All right, so we want to match each of these descriptions. Honestly, some of these have more than one correct answer. However, let's just choose the absolute best answer. If something has two congruent sides, we can say that's isosceles. That seems pretty cut in stone. If it has only one obtuse angle, that's going to make it an obtuse triangle. If it has all 60-degree angles, each of those angles are acute. It could be acute, but it also would be equiangular since they're all 60. It turns out it's also equilateral. This one has several choices, but I think equiangular is our best choice because all of the angles are equal. We're going to put D there. If it has no congruent sides at all, that is a scalene triangle. You have this in your video notes on congruent triangles. Only one right angle makes it a right triangle. 3 congruent sides, it has equal lats, equal sides. That's going to be A. And then 3 acute angles makes that an acute triangle there, okay? All right, in number 2, we do have to justify our answer here when we're finished. So let's see what that looks like. It tells us that triangle AMG is isosceles and the base is AG. If that's the base, that makes those two sides the legs, and we want to find the value of x. Well, because I know that the legs are congruent in an isosceles triangle, that is going to justify my answer. It's what drives the equation I write. I know that x plus 1.4 has to equal 2x plus 0.1, and we want to solve for x. So subtract x from both sides, and then subtract the 1/10, and we end up with just 1 3/10 for x. To find the length of a leg, we'll want to plug it in right there. 2 times 1.3 plus 1/10. 2.6 plus 1/10 will be 2.7. And then to find the length of the base, we want to plug it in here. So we'll have 3 times that 1.3 minus the 4/10. So that's going to be 3.9 minus the 4/10. We'll have 3.5. In number 3, if you just look at these triangles, there are a pair of congruent vertical angles. I do have angle, angle, side, and angle, angle, side. So I could say this triangle, I could name it LPS, LPS. It is congruent to, I started with the single angle, I went to the double, so this would have to be ZPA if I were matching up the parts, and they are congruent by angle, angle, side. This is true, okay? However, if you look at this statement says that SLP is congruent to ZAP. There's something wrong with this statement. Namely, we can see that L and Z are congruent. In the statement I wrote, they're sitting in the same spot. But if you come up here, L is in the middle of that statement and Z is the first letter. Those parts are not matching up. So we have to say, no, the parts don't match. Or not the way the statement is written. Okay, so this is really the answer, but I can see why you would say yes, because they really are congruent. All right, and number 4, we do have a pair of parallel sides. So I know that HT is running parallel to SF. I'll just go ahead and extend those. These are parallel to each other. They tell us that angle H is congruent to angle S, that's already there, and that segment HT is congruent to segment SF. So all of that's given. And already I can see I have a pair of angles and a pair of sides. This segment is a transversal that crosses those two parallel lines, and notice the next statement is saying that angle F, which is this one, is congruent to angle HTO. So HTO has T as the vertex. Why are those two angles congruent? Well, if you ignore that segment and just look at the parallel lines and the transversal, this angle is sitting in the same position on both of those lines. That makes them corresponding angles. And parallel lines always form congruent corresponding angles. So the parallel lines are going to result in congruent corresponding angles. And now you can see that we have two angles and the side that connects them. So we have the angle and then the side and then the angle. Angle, side, angle is the congruency test to prove the triangle's congruent. All right, number 5 was really the first paragraph proof we had seen. Let's start with what we've been given. Segment LE is bisecting angle L, and this is angle L. So if it bisects angle L, that means that this piece, which is angle GLE, is congruent to this piece, which is angle ULE. So how did I know those were equal to one another? Because I knew what the word bisect means. Only what am I bisecting? So by definition of an, so we know this word should start with a vowel. Well, it's a bisector, but in this case, what's it bisecting? It's bisecting an angle, so we're calling that an angle bisector. So I know what it means to bisect an angle. It means to cut it into two different pieces. So anytime we use the word definition, it's just saying I know the meaning of that word and I'm going to apply it. All right, then we know that LE is congruent to LE. So this segment is congruent to itself. Anytime that happens, that's the reflexive property. And then LE's perpendicular to GU is given. So now we're back to the given, and that symbol, the upside down T, does mean perpendicular. Well, what does it mean for two segments to be perpendicular? It means they're going to intersect, not like this, but at a right angle. So we can mark that. LE is perpendicular to GU. That means it's going to form right angles down there where they meet. And that's what we say next. Angle GEL and angle UEL are right angles by the, how did I know those are right angles? I knew what the word perpendicular meant. So it's a meaning again. It's by the definition of perpendicular. So therefore, these two angles that we mentioned right here, GEL is congruent to, I don't know why they switched the letters around, but notice that E is still in the middle. Angle LEU, these two angles are congruent to each other because right angles are congruent. They're going to be equal in measure. And so what do we have marked? Once again, I have two angles. I have an angle and the side that connects them marked in this triangle. This will also be angle, side, angle. All right, so I mentioned this in class, that on these problems on the back, you're actually kind of running through what you know. Even mentally, you're probably solving it, just kind of using a bit of intuition, but these two angles are congruent, these two sides are congruent, and I know that this side is congruent to itself. That's enough information to say, beyond a shadow of a doubt, that the triangle on the left is going to be congruent to the triangle on the right by side, angle, side. So if those are congruent, that means that this angle has the same measure as that one, And these two angles form a linear pair. I know that they have to add up to 180 and they're equal. So more specifically, they both have to be 90. 90 plus 90 will give us 180. And remember, once you have congruent triangles, by CP/CTC, all the rest of the parts will be congruent. So these little pieces down here will be incongruent and so on. We could reflect the triangle on the left over segment CD, and it would be a perfect match with the triangle on the right by a rigid transformation. So if AB is 11, AB is the whole entire thing, then how far is it from A to D? Well, it was split into two equal parts. So 11 divided by 2, that's going to give us 5.5 centimeters. And then they want the measure of angle ADC, where D is the vertex. ADC is this angle, so that's a right angle, and that's going to be 90 degrees. Number 2, the same exact thing is happening here. So you can see that this triangle's isosceles. I could have done this problem the same way. It's isosceles, so the angles across from those sides will be congruent. I know that B, which is across from side CA, has to be congruent to A, which is across from side CB. So these triangles are congruent by angle, angle, side. And then again, the same thing happens. All the rest of the parts have to be congruent to each other. That's congruent to itself, and each of those little pieces will be congruent, okay? Again, you could reflect the one on top down to the one on the bottom. All right, so this time they tell us that angle A is 70 degrees. If A is 70, then so is B. And if we zoom out and look at the big triangle, we know two of the three angles. 70 plus 70 is 140. And so all of angle C up here needs to be, C is 40 degrees, but it's been split in half by this segment. So each of these pieces are 20 and 20. And they ask us for the measure of angle ACD, which is just this part right here in blue. And that angle is 20 degrees. And then they tell us that it's 3 centimeters from A to D. And the question is, how far is it from A to B? Well, those are two equal pieces. So 3 plus 3, it'll be 6 centimeters. All right, number 3 is very similar to that. Pay attention to the markings. These are all marked identically. That makes them all equal angles, and this is going to be a triangle with angles that are 60. And then notice this is marked the same as well. So that's going to be 60 and 60. And when we look at the smaller triangle, that makes this angle up here 30. And I believe that's what we're asked to find, ADE. So angle ADE has D as its vertex. So that means we want the measure of that angle right there, and that's 30 degrees. And then in order to find DC, we know that AE is 3.5. So from here to here is 3.5, but these two triangles are congruent. So that makes this piece 3.5. So this side is 7 units long. And then this triangle also has angles that are 60, 60, and all of angle D up here would be 60. Anytime a triangle has all equal angles, it also has all equal sides. So we've been asked to find the measure of side DC. Well, that's going to be equal to this side, and we can find that side by adding 3.5 and 3.5. So that is 7 centimeters there. All right, we have a proof. It's a pretty straightforward proof. We've been told that angle R is congruent to angle S. I know that because it was given. We've also been told that HR is congruent to SE, and that was given. How do I know that angle HUR, which has U as its vertex, is congruent to EUS? HUR and EUS, those are the two angles across from each other. Those are vertical angles. So vertical angles are congruent. And then just look at our diagram and decide what we have marked. This time we do have a pair of angles, but the side that connects them is not ticked, it's over here. So we have an angle, and then the side. This will be angle, angle, non-included side. And then you can see that H and U and E and U are in the same spots in this statement, the first and third letters, so they correspond. So those corresponding parts are going to be congruent since I have congruent triangles, CPCTC. All right, and then finally, we're just trying to decide if we have the right type of information to see if we have congruent triangles. So we know that AB is parallel to CD. These two sides run parallel to one another, not these. And this is a transversal that's cutting those. So here's an angle and here's an angle formed by the blue and yellow. Those are alternate interior angles. So I know that because the lines are parallel. Then they tell us that segment AD is congruent to segment BC, not parallel, but congruent. So we've taken care of that. So we have an angle and a side. And the only other thing I know is that this segment that they share is congruent to itself. But notice that this angle does not fall where the two sides are connected. We have a side, and then an angle. That's the dreaded angle side, side, and that's not a valid test, so we'll write it this way just to be, no matter what though, that's not a valid test. So we have no way of knowing for sure if those triangles are congruent. All right, in the second one, it's asking me to look at triangle ADB. And since that's overlapping one that's already there, I'll just sketch it really quick. So we have ADB, and it overlaps ABC. So I'll just draw those two triangles separately so I can mark them better. So we know that AC is congruent to BD, AD is congruent to BC, and that's all we've been given. But we can see they share the side down here where it turns a little green. That side's congruent to itself by the reflexive property. So I have three sides in one triangle congruent to three sides in another. I just want to be sure I name it well. So ADB, if I start at A and go to B, that takes me along my double and then my single ticking. So I would need to start at B and go in this direction. So this needs to be triangle BCA, matching up the parts. All right, and number 3, we've got a pair of angles, a pair of sides, and we know that those vertical angles are congruent. So these are going to be congruent by angle, side, angle. The S is falling in between the two angles. That's our congruency test. And when we name it ABC, we start at the single angle, we go to the unmarked, and we end up at the vertical. So we have to start at the single, go to the unmarked, and end at the vertical. We're going to call this triangle EDC to be sure we're matching the parts up properly. In number 4, we're told that segment CD is bisecting angle C. So this angle up here is cut into 2 equal pieces. Then it goes on to say that segment AC is congruent to BC, and now we're out of given information. But these two triangles share side CD. So this has nothing to do with this problem. If you could cover it up, we're just looking at these two triangles. So they're going to be congruent by, if you look at a single triangle, we have a side, an angle, and then a side, and it's the angle where the two sides are connected at C. So these triangles are congruent, by side, angle, side. That's going to be our test. and they did ACD. They started on the single side and went down the shared side. So we would need to do BCD to match up those parts. All right. And then finally, number 5, we want to find out these two triangles. So ABD is here, and CBD is here. And once again, those two triangles overlap each other. They do share that side down there. But let me just draw those separate as well. So we have ADB, and then we have DBC. Okay, so this is the pink one. And we said they share that side. So that's congruent to itself. They tell us that segment AB is congruent to CD, and they tell us that angle CDB, so CDB is this angle at the turn, and ABD is that angle. So why are those triangles congruent? It's going to be side, angle, side. It's the angle where the two sides are connected. The only thing we really need to check is the statements. Are A and C congruent? They're both the unmarked angle at the end of the double. Are B and D congruent? Yes and yes. So that seems to work. The parts are matched up.